Hello everyone, welcome back to ptet.chemistry channel. So this is work 4, is 40 multiple choice question, just like a full paper 1 in the Cambridge International O-Level or the IGCSE level chemistry. Okay, so chemical structure and bonding is a really big topic comprising of metallic bonding, covalent bonding, as well as ionic bonding. So all these chemical bonding, they're now jumbled together in this 40 multiple choice question. The first caution that you should exercise when you do multiple choice question is do not guess unless you really have to, and they should only be used for like a couple of questions that you really have to, because you will go into a multiple choice being fully prepared. Okay, so when you don't have enough knowledge, when you don't cover everything that you should have covered based on what the learning objective, that is basically what the syllabus says you should cover, you always will run into problem. Okay, multiple choice is one of those where you need to be careful at reading as well. So that's why we underline, we circle, we scribble. When I say we, I mean that's what I normally do, and that's what I expect you all to do as well when you address multiple choice questions. Otherwise, these kind of tutorials, they are meaningless because you'll just do your way, and I'm just telling you that there are better ways to think about a question, that is to remark on it so that it's clear for you when you have to check your work. Otherwise, you have to work from the very beginning again and read the whole thing again when you should have read it the first time, and remind yourself the second time or the third time later on, especially if you're doing this as part of revision, which this one is, as a homework, and you will look at it like maybe a few weeks from now or a few months from now, and you will be reminded of what you have done because it's your paper, it's your work, and it's your writing. Okay, so whenever you get something wrong for multiple choice question, try to understand why you get it wrong and how to get to the correct answer. That is more important than actually just getting the right answer itself. Okay, so let's get started with this first question. So copper wire is used to complete an electrical circuit. So this short terminal, this is a symbol, this is an electrical circuit symbol which you will have done in lower secondary. The short one represents minus, the long one represents a plus terminal. Anyway, copper is a metal, is in the transition metal series. Transition metal is that huge block that separates group 2 and group 3 in the periodic table. So this is element number 29, proton number 29, or atomic number 29, because atomic number is the same as proton number. It tells you the number of protons in the nucleus of an atom. So we know it's a metal. Copper is a metal. In fact, all metals are elements, which because they only consist of one type of atoms. All right, so that is a giant metallic structure. When you imagine giant metallic structure, you would have the cations. I'm not saying that it's definitely singly positive charge. I'm simply saying that these are cation, the charge of which you will probably find out that copper tend to form copper 2 plus ion, and then you will have a lot of electrons, and these electrons are the delocalized valence electron. It's not all the electrons in the atom, it's just valence electrons, and you only consist of one type of atom still. Okay, they are not exactly atoms, but you only have one type of cations, but it's still essentially atom because the electrons has just come from the outermost shell. All right, so this is element because it's a structure of a metal, giant metallic structure. So when you have a current flowing, so in physics you will have learned this term called current. Current results in electricity. So current is a flow of electrons. Okay, so it's a flow of electrons. So it's only the electrons that move. Electrons have negative charge. Electrons have negative relative charges, and therefore they will move towards the positive terminal because electrons are negatively charged, is attracted towards the positive terminal. But the positive ions do not move. Okay, they stay in position means they do not move, and that's correct. Positive ions move is incorrect. Positive ions stay in position because current is a flow of electrons, not the ions. Okay, and electrons are negatively charged, they will move towards the positive terminal, not the negative terminal. Question 2. So again, this is basically describing the structure of a metal, a lattice of cations or positive ions in a sea of delocalized valence electron. In a lot of textbooks, you will see it as sea of electrons, but it's important that you remind yourself it's valence electrons. instead of all the electrons, which is not clear from just looking at sea of electrons. All right, so what changes take place to the electrons and positive ions? Again, this is basically the same as the first question. This is just a different way of asking it. Here they give you in a wordy form, here they give you in a table form. So what happened to the electrons? The electrons move towards the positive terminal. All right, so the electrons move, and therefore the electrons will be replaced by new electrons because you leave your original position, you move towards the you move towards the positive terminal, because there is what negatively charged electrons will be attracted towards the positive terminal. The positive ions do not move. So based on what we said previously, it's the current that is the flow of electrons, not the cations. So the cations do not move. If they do not move, they remain unchanged. So option B is the answer there. Question 3. This is very direct. So in which of the following is there a lattice of positive ions in a sea of delocalized valence electrons? So again, I would advise you to actually use delocalized, sea of delocalized valence electrons, because it's just a matter of standard. Just because textbook always say like that, you should always remember that it's the valence electron that get delocalized, they get attracted to the positive ions. We are looking for metal. This is metallic structure. This is metallic bonding. Okay, so that is describing a giant metallic structure where the bonding is metallic bonding. We are looking for metal itself. This is an ionic compound consisting of K plus and Cl minus, or you can imagine it as being KCl. Solid graphite is an element. In fact, it's a giant molecular structure, as you will have learned in class as part of your case study. Carbon graphite, carbon diamond, as well as sand, which is silicon 4 oxide, which is SiO2. So there is a giant molecular structure. This is giant molecular structure. This is a compound consisting of two different elements bonded in a fixed ratio, chemically combined in a fixed ratio. Okay. Question 4. So we have two statements about metals. It's asking us which one is correct. Okay. So if you read the first bit, it has a lattice of negative ions. That is definitely incorrect. It has a lattice of positive ions, or what we call cations, in a sea of delocalized valence electron. So one is already incorrect because of negative ion there. When we see that, it says both statements are correct, that is wrong. Both statements are correct, that is wrong. Statement 1 is correct, that is wrong. There you go, there's only one answer because statement 1 is definitely wrong. So when you say both statements are correct, you can cross out A and B. Statement 1 is correct, you can cross out C as well, because we know statement 1 is definitely incorrect. Okay, so statement 1 is incorrect. Statement 2, electrical conductivity for metals, not for ionic compounds, not for covalent compounds, but for metals, is to do with the movement of free electrons. Okay, so these are the delocalized valence electrons, and these delocalized valence electrons are free to move. Okay, that's why we say free electrons, or the delocalized valence electrons are free to move. They are mobile, therefore you conduct electricity. Number 5, just reiterating, just reinforcing, just repeating what I just said like literally a moment ago. Conduction of electricity by metals is due to the movement of electrons only, not the cations, because the cations stay at the same place. They are not replaced by any cations. The electrons, however, they move towards the positive terminal. They'll be replaced by new electrons as the current flows through the circuit. Okay, and you do not have negative ions, because just like the previous question 4, you do not have a negative ion, you have positive ions in a sea of delocalized valence electron. Just to recap you on the structure, which you should be able to draw them of the same shape for cations, as well as the delocalized valence electron, the sea of delocalized valence electrons interspersed in between, so that you get attraction between the cations and the sea of delocalized valence electrons. That is the definition of metallic bonding. Question 6. So all of these substances can conduct electricity. All right. So which substance conductivity is not due to movement of electrons? Aluminium is a metal. When you are a metal, you have metallic bonding. You have giant metallic structure. So structure and bonding. Giant metallic structure, it has metallic bonding. It's to do with free delocalized valence electrons that are free to move. Okay, so we said the delocalized valence electrons are mobile or free to move, therefore they can conduct electricity. So not A, because it asks for not due to electrons. All right, graphite is to do with each carbon only uses 3 out of 4 valence electrons for bonding to 3 other carbon. You should know the structure of graphite. Just freehand draw the hexagon. Okay, and you should be able to appreciate the diagram. Yep, I think my hexagon is fine. So each carbon is bonded to 1, 2, 3. Each carbon in the graphite layered structure is bonded to 3 other carbon. So each carbon in the graphite layer, they have 1 free electron to conduct electricity to conduct electricity very well along each layer of the graphite. So graphite conduct electricity due to the presence of 1 free electron per carbon atom along the horizontal layer of graphite. Lithium chloride is a metal and non-metal, so they form ionic compound. Group 1 and group 7, cation from group 1, anion from group 7, and you get this ionic compound. So the reason why ionic compound conduct electricity in the aqueous as well as in the liquid state or molten state is due to the movement of free ions. Free ions, not electron. Okay, so C must be the answer. Mercury is a liquid metal. So in the whole of periodic table, there are only 2 liquid, one of which is mercury. It's a metal, but it's a liquid at room temperature and pressure. The other one is liquid bromine. Bromine is in group 7, is Br2, so it's a simple molecule that is a liquid at room temperature and pressure. Only 2 elements in the whole of periodic table are liquid, one of which is mercury, the other one being liquid bromine. Number 7, which statement shows that graphite and diamond are different forms of the same element? The other name for it is called allotrope. So allotropes refer to different forms of the same element. You want to get, what does the question say? Which statement shows that there are different forms? So both of them have giant molecular structure. So there is similarity. That is not to do with differences. So A is out. This is to do with similarity. Okay, so both of them will have high melting and boiling point because you need to break a lot of strong covalent bonds between the carbon atom because you'll be melting a giant molecular structure. Complete combustion of equal masses. So these are carbon, both of them are carbon. Of course, diamond is a very expensive source of carbon compared to graphite, which is present in your pencil lead, a very cheap source of carbon. They will produce equal mass of carbon dioxide and no other product. That is correct. So you haven't really done a lot of complete combustion. In fact, you haven't done combustion yet, okay? So combustion means you burn in excess oxygen. And when you burn in excess oxygen, which exists as O2 at room temperature and pressure, you will just get CO2, produce equal masses. Yep, because you just have carbon reacting with oxygen and they give you CO2, and that equation is balanced because you got 1 carbon and 1 carbon. So CO2 refer to 1 carbon, 2 oxygen. There's 2 oxygen here and there's 2 oxygen. So this equation is perfectly balanced. There's no other product. So both of them again similar because both of them produce the same amount of carbon dioxide because they are equal masses to begin with. Hello everyone. I had to cut the reasoning for question 7 in between because I found out that I had reasoned incorrectly previously, and instead of editing the whole video, I want you to see that it's very easy to make mistake with this kind of question because these are statement type. So I admit my mistake. So this time I managed to actually edit it before the video actually goes online. So hopefully this would be the way to go forward, rather than me having to edit it in a separate text, and then people who only get the video without reading the text, you might not understand what is going on. So what exactly is going on here? So previously I put down D as the answer, but even though this is a difference, so this is quite a tricky thing, and a lot of people, including myself, would have put this down because we think that this is a different property. But this is a different property as a result of different structure of diamond versus graphite. But here, they are trying to say that there are different forms of the same element. That's the definition of allotrop. So diamond and graphite are different forms of the same element. So the idea here really is same element, only different form. Because they are the same element, you have the same balance equation. When you burn graphite, you burn in oxygen to give you carbon dioxide. It follows this equation. When you have diamond or graphite, it's the exact same equation, whether you're burning the really cheap graphite or whether you are burning diamond, which is a really expensive source of carbon dioxide, because you exactly get the same product by combusting or by burning diamond in excess oxygen. So this is actually a correct statement, and this is actually the one that you want to explain that different forms of the same element will give you the same equal mass, because you started from equal mass of graphite, therefore you get equal mass of CO2. What I'm saying is that whatever mass that goes in here plus this will give you whatever mass is here. This is the idea of conservation of mass. Whatever goes in equal to whatever comes out. If we have same mass of graphite and then same mass of diamond in another reaction, we will get same mass of carbon dioxide, because both of them follow the same equation. Hence the idea here really is that B is the correct answer and not D. Now graphite and diamond have different melting point, so again that does not tell a difference, because both are very high melting point because of giant molecular structure, which is in option A. So both of them have giant molecular structure, like I said. So both of them require breaking a lot of strong covalent bonds. So different melting point here actually doesn't tell you too much about different forms of the element carbon, because they are both giant molecular structure. D is the definite answer. One conduct electricity, diamond does not. Graphite conduct electricity because of what we said in the previous question. Each carbon is bonded to 3 other carbon instead of 4, just like in diamond. So there's 1 free electron on each carbon atom in graphite, so that each free electron on each carbon, they get delocalized along the horizontal layer, and therefore you can conduct electricity due to the movement of free electron per carbon atom. Okay, 1 free electron per carbon atom delocalized along the graphite layer can conduct electricity. In diamond, each carbon is bonded to 4 other carbon, so there is no free electron at all. No free electron on each carbon, because you form 4 covalent bond. If you form 4 covalent bond, that means you use all the 4 outer shell electrons of carbon atom, 4 valence electrons of the carbon atom, for forming covalent bonds. Question 8 is a very straightforward question. Which one is a compound? Remember the definition of a compound: a pure substance that consists of 2 or more elements, not atoms, 2 or more elements that are chemically combined together in a fixed ratio. Not atoms, I emphasize not atoms, but 2 or more elements. A is a mixture. In fact, you got around 79% nitrogen, you got around 20% oxygen, and etc. etc. Okay, carbon can be in fact there are different forms of the element that you get in the periodic table. Carbon is element number 6. Periodic table of the elements that is given for you for free in the real exam. Periodic table of the element. Carbon is element number 6. It is not a compound, but you can have different forms of the same element. It's called graphite, diamond. Those are part of your case study. Oxygen is also an element. It's element number 8 in the periodic table, but it exists as molecule. It exists as O2. That is because it wants to get a noble gas configuration for each oxygen atom. However, the oxygen that you see in the periodic table is for one single atom. it's still single type of atoms because they are bonded to themselves, therefore it is still an element. Okay, steam is just H2O gas in the gaseous phase. The H2O molecule is still the same because it's a simple molecular structure. So it's a simple covalent molecule. We are not breaking the covalent bond when we go from solid to liquid to gas because it has a simple molecular structure. We are just separating the molecule further and further and further apart, going from solid to liquid to gas. All right, for simple molecular structure. So that is a compound because it's got two or more elements chemically combined together in a fixed ratio. So 2 hydrogen and 1 oxygen. Question 9, so case study about graphite is asking for which one is not correct. Not correct meaning false. So you need to read carefully. Yeah? It burns to give carbon dioxide. So if you have carbon, which is graphite, reacting with oxygen, you get CO2 and no other product because you started with pure element, carbon, which is present in graphite, plus oxygen, you get carbon dioxide. That equation is balanced. So this is true, it's not false, so it's not what you want. It is a carbon compound. Compound is wrong. It's an element because there's only one type of atoms in the whole structure of graphite. So B must be false. B is the correct answer for what they're asking, which is not correct. Giant molecular structure is correct. You have to break a lot of strong covalent bonds between the carbon-carbon atom because of the giant molecular structure. It's used as a lubricant. And this is why because you have weak, it has a layered structure and you have weak van der Waals, forces of attraction between the layered. So it doesn't take a lot of energy to break the weak intermolecular force between the layer, to break the weak van der Waals forces of attraction between the layers. That's why it's very slippery. That's why it's used as a lubricant. Okay. Number 10. Which one represents the structure of sand? So this is silicon 4 oxide. So silicon 4 oxide is a case study. So given here, the black one is a silicon atom. So each silicon bonded to 4 oxygen because silicon is in group 4. So it's got 4 outer shell electrons. So silicon is group 4. So it's got 4 valence electron. So it wants to share 4 other electrons and it will form to single bond to 4 oxygen, and then each oxygen bonded to 2 silicon. Okay, so it'll be like so this one is group 6. It's got 6 valence electron. You would like to share 2 more electrons in order to get to fully filled outer shell, which is 8 electrons for this second period, which is second electronic shell, okay, for oxygen. So if I'm just drawing a hand sketch, which you should be able to do without even referring to this, of course you can see the answer is definitely A already, because each silicon is bonded to 4 other oxygen and each oxygen is bonded to silicon. If I'm drawing it freehand, it will be like this. Okay, so silicon, this is what you should practice drawing. Silicon is bonded to 4 oxygen. Each oxygen is bonded to 2 silicon. So it's not a double bond, it's 2 single bond. So each oxygen is bonded to 2 silicon. Each oxygen is bonded to 2 silicon. And of course, each silicon is again bonded to 4 oxygen. So I've shown 1. I have 3 more. This is to show the giant molecular structure. It just continues. So each silicon, 4 covalent bonds to 4 different oxygen. Same here, and that's essentially what they have shown there. Okay, so this is what you do when you are asked to sketch out or hand draw, which you should be able to do as part of your case study. If you can do this, there's no way you cannot identify this. All right, so trying to confuse you with CO2, of course, carbon dioxide. Carbon is just above silicon. CO2 is simple molecular. But SiO2 is your case study. It's definitely not simple molecular, not given the very high melting point, therefore indicating it's a giant structure, which in the case of SiO2, it's a giant molecular structure. So you need a lot of energy to break all these strong covalent bonds between the silicon and the oxygen atoms. Question 11, which statement is not correct? So again, which statement is false? All right. A is a mixture. That is true, as mentioned, around 78% nitrogen, around 20% oxygen, etc., etc. Ammonia, NH3 is a compound. The nitrogen and the hydrogen is combined chemically in a fixed ratio of 1:3, and you have more than two, well, you have two elements there, okay? So CH4 is also a compound, but seawater is not a compound because seawater has, salt, water, you have other mineral, you have other mineral salts, of course, in seawater. It's not just salt plus water. Therefore, that is actually a mixture. So seawater is a mixture of all these substances, well, among other things, of course. Number 12, which statement most clearly indicate that diamond and graphite are forms of carbon? So which one is allotropes? So again, this is very similar to a previous question. If I just scroll up, just now they say different forms of the element carbon. So it's quite similar to this question, but as you can see, there are different ways of asking the same thing. So here they say both are crystalline solid. So graphite is not really crystalline. Graphite is your pencil lead. It doesn't look crystalline at all, whereas diamond looks crystalline, okay? But option B is definitely correct. Again, I can write a chemical equation to show this. You will understand more and more of chemical equation eventually. But carbon graphite and carbon diamond, you just write as carbon because it's essentially just carbon, single type of atoms, just carbon. Oxygen exists as O2. It's a simple molecule at room temperature and pressure, simple covalent molecule. This is also a simple covalent molecule, CO2. I just talked about it in the previous question. Okay, you should be able to draw the dot and cross for it. Carbon form 4 covalent bond, oxygen form 2 covalent bonds. All right. So B is definitely not relevant because this is the same reaction for both diamond and graphite. Okay, so graphite conduct electricity, diamond is an insulator. Insulator means it does not conduct electricity. That is because there are no free ions, no free electrons, okay, in diamond, because each carbon is bonded to 4 other carbon. Each carbon in graphite is bonded to 3 other carbon, leaving you 1 free electron per carbon atom to conduct electricity very well along the horizontal layer of graphite. And sorry that I have to disturb this tutorial video in the middle of question 12 again, because it's the exact same problem as for question 7. So I hope you learned the lesson from what I talked about earlier for question 7 about my mistake. So this is a different way. Well, it's not really a different way. It's actually asking the same thing, but it's slightly differently worded. It's a differently worded question, but it's still saying that which statement very clearly or most clearly indicates that there are allotropes, different forms of the same element. Okay, so the idea here really again is same element, and therefore we are focusing on the same balanced chemical equation to show that whether you are diamond or whether you are graphite, you follow the exact same equation because they are exactly just different forms of the same element. You will still get carbon dioxide, and if you use diamond, it's just a very expensive source of carbon dioxide. But if you use 1 gram of graphite or 1 gram of diamond, you will get the same mass of carbon dioxide being produced from diamond or being produced from the same mass of graphite. Okay, so the conservation of mass idea really is whatever mass that goes in here plus whatever mass that goes in here will give you the total mass on the right hand side, provided the equation is balanced. Okay, so if diamond and graphite, you started with the same mass, you will end with the same mass of carbon dioxide because they follow the same balance equation. And I think previously I put down C as the answer, which again is also similar to my mistake in the last question 7. C is what seemed obvious because it's a different property. Okay, however, there's a result of structure and not showing that they are just different forms of the same element. Okay, so B is a chemical reaction, and this chemical reaction very clearly shows that these are allotropes by following the exact same equation and by having the reacting masses producing the same amount, the same mass of carbon dioxide when you start with the same amount of graphite and also diamond. Okay, so apology for the mistake. At least I'm able to correct it in this tutorial video before I have to correct it in the video description, just like some of my other tutorial videos. So keep an eye out for mistakes. Let me know if you spot any, and yeah, continue on with the rest of the tutorial. Remember, graphite is a layered structure. Okay, so C is definitely the best option there, because one conduct and one does not conduct. So make sure if these come out in a structured question, you'll be able to come up with these to describe these two as the different forms of the same element, known as allotropes. Question 13, element X. So this is an element, okay, does not conduct electricity and has low melting point. The fact that it has low melting point suggests that it has a simple molecular structure. So the other three different structure that you learn will be giant molecular, giant ionic, as well as giant metallic. Okay, all the giant structure would have high melting and boiling point. Low melting point straight away suggests that it's simple molecular structure. Okay, well, this one is factor number 2, does not conduct electricity. So graphite is out because graphite conduct electricity. Iodine is actually the answer we are looking for, because iodine exists as I2, just like Cl2 and Br2. It has a single covalent bond, which when you draw the dot and cross, that is actually wrong, because group 7 element has 7 outer shell electrons. So do not just draw what you want to see. This is display formula. In the dot and cross, you show every single outer shell electron. Unless the question specify that you should draw the inner shell, you always just draw the outer shell. I usually don't draw the shell at all, but that is a sharing of 2 electrons, which indicate this one single line, which is one covalent bond. Mercury has a giant metallic structure, and that is because, as mentioned, is one of 2 liquid at room temperature and pressure, but it's a liquid metal. It's a liquid metal at room temperature, which is 25 degrees Celsius. This is a solid metal. This is a group 1 metal. So group 1 are metal, and metallic bonding does not have low melting point because, well, giant metallic structure would have high melting and boiling point. Number 14, which of the following is not a mixture? Not a mixture. Well, ethanol is pure. Okay, so ethanol is ethanol is a pure compound. That's all I can tell you. Okay, so petrol is a mixture of different substances. Steel is made out of iron plus other substances, which can include carbon, which can include chromium, or etc. Okay, depending on what kind of steel you want, depending on standard steel or not, you can add other metal to it, etc, etc. Tap water has dissolved ions. So eventually, when you start doing practicals, we will start to use distilled water, or what we call deionized water. Distilled water is what comes from distillation. So distilled water is also known as deionized water. Okay, pure H2O, no dissolved ion. The tap water has dissolved ions. That's why we don't use it in our practical experiments. We have bottles of distilled or deionized water to wash all your stuff for doing practical experiments. So be very careful the difference between tap water and distilled or deionized water. Number 15, why do graphite and diamond have different physical property? Physical property typically involve boiling point, melting point, but also involve electrical conductivity. When you do more and more topic, you will see that physical property also include density as well, but we won't be talking about density for graphite and diamond. So diamond has a giant molecular structure, but graphite does not. This is wrong. Both diamond and graphite have a giant molecular structure. That's why both have very, very high melting and boiling point, because you need to break a lot of strong covalent bonds between the carbon-carbon atoms in this giant molecular structure. Diamond occurs naturally, graphite is made artificially. Okay, so if you think graphite is made artificially, then you must be highly mistaken, because when you take charcoal you can see that you can write with charcoal, because charcoal is pretty much like graphite, okay, and it's a natural source, okay. You can definitely get graphite quite easily. Okay, so that is not true. In fact, diamond can be made artificially under a very intense pressure. It's more expensive than naturally created diamond, but there's a huge industry for it. Especially you want pure diamond for making your drilling bits, because you want it to last very long, especially in petroleum and also mining industry. Graphite is ionic. Straight away that is wrong. Ionic bonding exists in ionic compound. Graphite is an element. Okay, graphite only contains of carbon atom. Ionic bonding only exists in ionic compound. Okay, therefore this is not a compound. All right, so C is definitely out, which means the answer must be D. So they contain carbon atoms covalently bonded to different numbers of other carbon atoms. 3 for graphite, 4 for diamond. This is the reason why this graphite can conduct electricity, because you have 1 free electrons on each carbon in the layered structure. This is why diamond cannot conduct electricity, because all the 4 valence electrons are being used for covalent bonding. So that's why there are no free electrons for conduction of electricity at all. Number 16, in which pair is each substance a mixture? Well, A is a mixture, but water is compound, is pure substance, okay? You haven't really done lime water, but lime water is this calcium hydroxide in water, okay, whereas this one is also water. So calcium hydroxide in water, that is a mixture, is a solution. Lime water solution is a mixture, okay. Water is compound, so water is H2O, is compound, okay. Quicklime and lime water. How do I say this? This is a solid, it's the pure substance. Before you dissolve it in water, and then you get this solution, which is a mixture. Before you dissolve something to get lime water, you have this quicklime dissolve in water and give you lime water, okay. We are looking at seawater, which is a mixture of water, salt, other dissolved minerals, and A is a mixture of various gases, as I mentioned earlier, nitrogen mostly, but you also contain oxygen, which we need for respiration and to survive, okay. And of course there are other gases, which include CO2 and various other small bits of other gases, okay. Question 17, which 2 substances are elements with a giant molecular structure? This one should be pretty straightforward. Diamond, graphite, okay. So sand is SiO2. That is your other case study. It's called silicon 4 oxide. That is a compound. Is a compound with giant molecular structure, okay. Methane and iodine, CH4 is also your case study. Iodine is also a case study. The SiO2. So CH4 and I2 both are simple molecular. So both methane and iodine have low melting and boiling point, compared to much lower compared to this giant molecular structure, which have melting point like close to 4000 degrees Celsius. All right. Number 18, which statement explains why magnesium oxide has a very high melting point? Magnesium oxide, the fact that it has an oxide is an ion of oxygen, is O2 minus. So magnesium oxide refers to MgO, because Mg2 plus O2 minus. So the LCM of 2 electrons being transferred, being lost from the magnesium atom to give you Mg2 plus. Both the electrons are being gained from the O2 minus. Okay, so you just need one of each. Therefore, the stoichiometry, basically the ratio of the cation and the anion is 1:1. The formula of magnesium oxide is MgO. Strong covalent bond, straight away you can cross that out, because, well, it is not a covalent bond, it's a ionic bonding. Okay, crystal lattice resemble that of diamond. That is again incorrect. Diamond is giant molecular lattice structure. Okay, usually we don't talk about lattice, but it's basically a lattice for the structure itself, okay? Just like giant ionic structure is a giant ionic lattice structure. Magnesium ions are strongly attracted to the oxide ions. Well, ionic bonding, electrostatic force attraction between oppositely charged ions. So C is definitely correct, okay? And you haven't really done exothermic, but you know, the high melting point is got nothing to do with exothermic or endothermic. It's got to do with definitely how strong is the bonding that you are forming, and the bonding that you are forming is ionic bonding between oppositely charged ions. You need a large amount of energy to break the strong ionic bond between the oppositely charged ions. That is how you address or explain why ionic compounds have high melting and boiling point. Number 19, so you have a concentrated, this is aqueous, that means in water. Okay, so it's a solution, so it's a mixture in water of sodium chloride. This is a salt. Okay, so you want to think about boiling. When you boil, you are not going to boil the sodium chloride because this is an ionic compound. This is a giant ionic structure. The structure is giant ionic structure. So to boil NaCl, you need a large, huge amount of energy, you know, to actually break the strong ionic bond between the Na plus and Cl minus. Okay, Na plus and Cl minus. Typically, you will see that written as NaCl, but it's not covalent bond. It's oppositely charged ions. Therefore, there is a metal and non-metal. Okay, so cation, anion. Not obvious from here, obvious from there. That's why you need to keep an eye out for this kind of chemistry vocabulary. Oops. NaCl is probably the most basic of your chemistry vocabulary. Okay. So we know pure water. We know pure water boils at 100 degrees Celsius. Okay. So salt. You know, when you cook spaghetti, you add a little bit of salt to the water because it helps to increase the boiling point. Okay, so the answer there will be D. So moving on to the next question, question 20. In which pair of substances does each have a giant molecular structure? So each of these is really in your case study, apart from maybe iodine, but having come across iodine, you should know there's I2. Diamond is a giant molecular structure. I2 is a simple molecular structure. So there exists a simple molecule like this. With weak intermolecular forces between the molecules. So if you didn't know this before, now you know that all the halogens, all the group 17 molecules, because that's how they exist at room temperature and pressure, they have weak intermolecular forces between the discrete single molecules, because there's simple molecular structure, there's giant molecular structure, so iodine is out. Diamond is giant molecular structure. Silica or sand is SiO2. This is silicon 4 oxide. So that has a giant molecular structure. Both of these have giant molecular structure. Methane is CH4. CH4 also, well, it's a gas at room temperature and pressure, which is already a gas at 25 degrees Celsius. It already boils below 25 degrees Celsius. It has low boiling point. CH4 has a simple molecular structure. Okay, so CH4 is simple molecular structure. SiO2 has giant molecular structure. Question 21. Which material has the highest melting point? We are looking for giant structure, which of course, you know, it could be giant metallic, it could be giant ionic, it could also be giant molecular. Ammonia is a simple molecule. CH4 is a simple molecule. H2O is a simple molecule. These are all in the syllabus under simple covalent molecules under covalent bonding. Sodium chloride is an ionic compound. Like I said earlier, you should have better vocabulary for chemistry, especially now that you know Na plus and Cl minus give you NaCl. Giant ionic structure consists of oppositely charged ions, giving you ionic bond between the oppositely charged ions, and therefore require a large amount of energy to break the strong ionic bonds between the oppositely charged ions. Therefore, high melting point compared to simple molecules, where I'll just be breaking weak intermolecular forces between the molecules, because I'm not breaking the covalent bond, not for some molecules that have simple molecular structure. 22. This is arsenic tri-bromide. So this is actually arsenic because one arsenic, 3 bromine atoms. Okay. So this is a simple molecule. As you can see, that exists as simple molecule, one molecule like this. Arsenic is in group 5, so it's got 5 outer shell electrons. It uses 3 outer shell electrons for forming 3 covalent bonds, single, single, single. So you still have 2 more electrons that are non-bonding. So simple molecular structure would mean that they have low melting and boiling point. I'm looking at around this value are considered quite low. This is in degrees Celsius. This value are considered quite high. That suggests giant structure. Okay, so I can cross out C and D just like that. So looking at electrical conductivity at room temperature, so that one conducts, so not true for simple molecular structure. So simple molecular structure do not conduct electricity at room temperature. In fact, they just don't conduct. Okay, apart from things like HCl, for example, you will see HCl is hydrogen chloride. I'm pretty sure it will come out later on in one of the questions, but in case it doesn't, you get H3O plus Cl minus. H3O plus is basically H2O plus H plus. Now you have free ions in solution that can conduct electricity. This one is simple molecular as part of your case study under covalent bonding. Simple molecular structure, when you did dot and cross, is in the syllabus. You're supposed to know this. Candidates should be able to do this because they should be able to appreciate whatever is the minimum expected in the syllabus. So we have a table that shows properties of diamond and graphite. So case studies again and again and again. As you can see, they are very popular case studies. So diamond cuts glass because the bonds in glass are stronger than that in diamond. That is not true. Diamond have very strong bonds, very rigid structure, very hard, and therefore very strong bonds, very hard diamond. That's why you can cut glass. So that doesn't align. That is not the correct reason for the property itself. This is a correct property. Diamond is a hard substance. There are many ionic bonds. Well, we are dealing with a giant molecular structure that has covalent bond within the network, not ionic bond. Graphite is a lubricant, so we are looking at breaking weak intermolecular forces, which this one, the name you probably need to know. This is called van der Waals forces between the layers. Okay, so that is the correct reason there. So graphite conduct electricity because you have free electrons, not free ions, because there's no ionic bond in graphite and there's no metallic bond in graphite. It's to do with free moving electrons because each carbon in graphite is only bonded to 3 other carbon. Carbon has 4 outer shell electron, 4 valence electron, uses only 3 out of 4 for forming covalent bond. So you still have 1 more electron on each carbon atom to conduct electricity along the layer. 24. Which of the following is a compound? A is a mixture. I think it's a repeat of something similar earlier. You have N2, which is around 78%, 79%, O2 is around 20%, and other gases making up the rest of the constituents. I say around because these are not exact values, so take my word for it, and you will learn something which is more exact later on, or you will know something more exact essentially. This is elements. I have a feeling this is exactly the same question as before, but anyway. So definitely steam is the compound there. It is definitely a repeat of something earlier. I forgot to take out this question and replace it. 25. So the diagram shows part of the lattice structure. Remember the lattice structures. This is a graphite. This is giant covalent structure. So sometimes you will hear me saying that it's giant molecular structure. you should know that the two mean the same thing. And sometimes there are questions that use giant covalent, sometimes they use giant molecular. I typically use giant molecular, but if you like giant covalent, you can stick with it for all your answers. But this is structure, the bonding present in there. It's covalent bond, but don't forget that you also have weak van der Waals forces between the layers. It's make it easy to slide because you are just breaking the weak van der Waals forces, but it still has a very high melting point because of the giant molecular structure. You need to break all the many strong covalent bond between the carbon atoms. These are alternating cations and anions. This is actually part of giant ionic structure. So that's why you see it's not just one single type of atoms, and they are not arrays of delocalized valence electron either. So it cannot be metallic because each of these is actually different particles. Okay, they are not electrons. Electrons are not particles. Electrons are subatomic particle. Okay. So we're looking at B being covalent, which means B is the only answer, really. Okay, because there's ionic, as I mentioned. So question 26, why does magnesium oxide have a very high melting point? Again, this is pretty much a repeat of what I have said earlier, so you can probably skip this question. It's definitely, there you go, it's definitely this question, all right? So it's the same as question 18. So 27, how are the structures of diamond and silicon 4 oxide similar? So well, both are giant molecular. I hope you know that, part of your case study. So both have giant molecular structure, very high melting and boiling point. They are not held by weak attractive forces. They both contain atoms arranged in planes. Arranged in plane is wrong. That is graphite, and diamond is not graphite. Silicon 4 oxide or sand is not graphite. They both contain ions. That is incorrect. Both of these are giant molecular structure. They do not have ions because they are not ionic compound. If A, B, and C are wrong, D must be the answer. And that is true because in diamond, or each carbon is bonded to 4 other carbon. In silicon is also group 14, just like carbon. So each silicon is bonded to 4 oxygen, and each oxygen is bonded to 2 silicon, just like that. You should be able to freehand sketch that each silicon is bonded to 4 other oxygen. Each oxygen is bonded to 2 other silicon. 28. Which type of bonding is never found in elements? Covalent. Well, there's a lot of example. Fluorine, chlorine. So each of these is an example of covalent bond, and each of these is an element because they only consist. The elements can be molecules. Element can also be atoms. So A is wrong. Ionic is definitely the answer because what do we talk about? We don't talk about ionic elements. We talk about ionic compound. Ionic compound because ionic compound never ever elements. Okay. Metals, well, you know, all metals, and metals are elements, including transition elements or transition metals. Van der Waals forces, if you have graphite, you have van der Waals forces between the layers of between each layer of graphite. And don't forget that van der Waals force is an intermolecular force, actually between between each simple molecule to the other simple molecule. You also have van der Waals forces. Okay, this is between simple molecules. Okay, for simple molecular structure. So anything with simple molecular structure, you will definitely have van der Waals forces as your intermolecular forces of attraction between your molecules. And these include noble gases, because even though noble gases do not form molecule, they exist as atoms. They are still simple molecular structure. You still have van der Waals forces of attraction between the atoms. All right. 29, you have hydrazine. Look at this. Nitrogen is group 5. Nitrogen is in group 5. It's got 5 valence electrons. nitrogen likes to form 3 covalent bonds, 1, 2, 3, in order to have 5 plus 3, 1 from this, 1 from the hydrogen, 1 from the nitrogen, to get up to 5 plus 3, which is 8 electrons in the valence shell. Same for this nitrogen, 1, 2, 3 covalent bond, 3 plus 5, 8 electrons in the valence shell for the nitrogen. Hydrogen, 1 outer shell electrons, share 1 electrons with the other atoms, therefore it form 1 covalent bond. So which description of the bonding in hydrazine is not correct? So read the question carefully, not correct. So nitrogen is in group 5, 5 outer shell electron, 5 valence electron, uses 1, 2, 3 for bonding. You still have 2 electrons because 1 there, 1 there, 1 there. You only use 3 out of 5, you still have 2 more. Same deal for this, 5 outer shell electrons, use 1, 2, 3, you still have 2 more. So each nitrogen atom has a non-bonding pair. This is a pair. Non-bonding means not involved in bonding. Not involved in bonding. These are non-bonding electrons. So that is correct. That is true. They are asking for which one is not correct. Okay. Each nitrogen atom has 4 bonding pairs of electrons. This is wrong. Only 3 bonding pairs, because 3 single covalent bond per nitrogen atom. If you have 3 single covalent bonds, that is 3 bonding pair, 1, 2, 3. Okay, so you already gotten the answer, you can move on, but I'll just very quickly show you what it is. Okay, if I show this nitrogen as cross, then I will show it with a dot for this other nitrogen. Sorry, I do not want to show double bond, I want to show single bond. So if I use triangle for hydrogen, then dot triangle for hydrogen, cross triangle hydrogen, cross triangle hydrogen, then I have dot for nitrogen, cross for nitrogen. So each nitrogen shares 1 of its electron with another neighboring nitrogen, which also share 1. That's why this is a single covalent bond. This is actually true. Each nitrogen shares 2 of its electron with hydrogen atom, 1 there and 1 there. Each nitrogen shares 2 of its electron with 2 hydrogen atom, with 2 times hydrogen atom. This is again true. And of course, we already found out that B was actually incorrect. B was not correct. Question 30. Materials can be classified by their chemical structures. You have 4 common types of structure. So giant metallic, giant ionic, giant molecular. So don't forget giant metallic. Don't forget giant ionic. Well, giant molecular is given, simple molecular is there. Okay, do not forget those giant stuff. So which one has a simple molecular structure? So the only one which is simple will have low melting point and also boiling point. This is high, I can cross that out. This is high, I can cross that out. Do not be quick to cross out 113 because even water boils at 100 degrees Celsius, so this is considered quite low. So it takes some knowledge in order to, and also experience, and also seeing more and more of these kind of properties and temperature for boiling and melting point to have an idea of your chemistry vocabulary. Okay, so do not straight away say this is high, okay, because you also have to consider other things. But these things which are typically more than 400 degrees Celsius is considered high, but I will not be very quick to say 400 is the limit. No. Okay, sometimes these are situation by situation basis. You have to take into account other factor as well. All right, so effect of adding water. All right, so covalent molecules. Okay, so when it's simple molecules, they typically they are insoluble in water. They don't just react with water. Okay, but electrical conductivity, this is one that give it away. Okay, good when solid. This is not metals. Okay, simple covalent molecules are not metal. Simple covalent molecules are not metals. So good when solid typically refers to metals, obviously, but you also have graphite, which is a solid, a giant molecular structure, but it conducts because graphite is one of those giant molecular structure. They are very unique compared to diamond and also sand. So I'm pretty sure since we said this one is wrong, so A is wrong, B must be the answer. This is why I said do not be quick to judge because of other properties, and this is not that high actually. Okay. 31, element W is in period 3, so you have sodium all the way to argon. It has a solid white oxide. You can say it's not argon. It forms a compound with oxygen. Noble gas are nice and happy on its own. It doesn't form a compound in oxygen. That's why noble gas are called noble gases, are unreactive. X is thermally stable. X is the oxide. Very high melting point. Okay, so it's one of those giant structure. Just like in the previous question, giant structure could mean giant ionic, it could mean giant molecular, it could mean giant metallic. But what I can say is it cannot be metallic because X is a compound. Well, X is a solid white oxide. It's between an element with an oxygen. This element is in period 3, oxygen is in period 2, so it cannot be oxygen bonded with oxygen, right? Okay, so X is a compound, therefore not a metal. Okay, that is why it must be giant ionic or giant molecular. X is slightly soluble in water. Slightly soluble in water. Okay, so giant molecular structure. What can we say? The fact that it's slightly soluble in water cannot be giant molecular. When you think about sand, okay, so what is your giant molecular structure? Diamond, graphite, silicon 4 oxide, which is sand, so or silica. None of these dissolve in water. None of this is even slightly soluble in water. So it cannot be giant molecular, therefore. Okay, so this thing cannot be giant molecular because of this, dissolve slightly in water. So we're looking for giant ionic structure. It has to be a giant 3-dimensional lattice or strong ionic. It has to be C because this is a wrong chemistry. It says strong ionic bond and then it says molecule. Do you see why it's wrong? It says ionic but it says molecules. So this thing is what we call contradict. When you write this in a structured paper, you do not ever put these two together. When you put ionic and molecule together, you are done. Okay, there's a wrong chemistry already. 32, cesium. Cesium is a metal in group 1, so 1 outer shell electrons. So it's a metal. Well, they already say it's a metal, so it's a giant metallic structure. And what else are they asking? They're asking about the bonding. So what about metallic bonding? Metallic bonding is an electrostatic force of attraction between, not between oppositely charged ions, because that is for ionic bond. So not A, it's between positive metal ions and the sea of delocalized valence electrons. So you only delocalize the valence electrons, not all your electrons. So B is definitely the best answer. It's definitely not sharing a pair of electrons because that is covalent bonding. And strong attractive force between atoms. This is like argon, helium, neon. Okay, so that is van der Waals. This is between atoms. That is for noble gases. They are simple molecules. Yes, they exist as atom, but their structure is simple molecular structure. So the structure of all the noble gases, they are all existing as single individual atoms, not molecules, because they do not need to share, they do not need to lose, they do not need to gain electrons. They simply exist as atoms, single atoms, simple molecular structure with just van der Waals, which is a intermolecular forces between the atoms. Okay, this is between the atoms. It's the same van der Waals that you get between the layers of graphite But graphite is special because of that van der Waals force attraction between the layers when it is a giant molecular structure. Question 33. So which substance could be potassium iodide? Potassium is a group 1 metal. Iodine is a group 7 element. Okay, so potassium iodide is an ionic compound. Is an ionic compound. If you are an ionic compound, you have giant metallic structure. Giant ionic structure. And we need to take a large amount of energy to break the strong ionic bond between the oppositely charged ion. It cannot be negative. That is law. That is law melting point. Room temperature is 25 degrees Celsius. This is below 0 degrees Celsius. So A and B are out. When molten means in liquid state. This is pure. This is not in water. It's not a solution. It's when molten. So you conduct electricity when you melt ionic compound, because the ions are no longer just in a fixed position. They are no longer solid. In fact, in liquid state, they are able to move freely. Okay, they have a little bit more freedom because they can slide past each other, and because you have free ions. All right, so now you have free ions, mobile to move, therefore conduct electricity. These are normally asked in theory paper. So in molten state, that is in liquid state, you have free ions, they are mobile to move. So it has to be C. Just because this is high, a lot of students will just see this. But again, what is the point of them giving you all the information when you're just looking at the most obvious thing without, going through the question? Yes, this is high, but this is also high. Make sure you read question carefully and not get tricked easily. This is why multiple choice tricks people who likes to fail, who likes to make mistakes. Okay, the lesser your mistakes are, well, the higher you will score. 34. Which statement about an ionic compound is not correct? Not correct meaning false. You need to know what is correct in order to be able to tell what is false. Ionic compound conduct electricity when dissolved in water. So that means aqueous. So when dissolved in water, you have free. Well, it's exactly the same explanation. You have free or mobile ions to conduct electricity when it's in aqueous or when it's in molten state. So this is true. This is true. So it's not what you want. B, it has a high melting point because of strong ionic bond between oppositely charged ions. Okay, so this is how we will explain it in a real structured paper, but this is given for us, so you need to be aware that you should write complete thing for your structured paper. It has a regular lattice of oppositely charged ions in a sea of electrons. That is incorrect. That one is for metallic structure. That is a giant metallic structure. So meaning to say this one is false and C is our answer because this is a false statement. Ionic bonds are formed between metallic and non-metallic elements because the metals like to lose electron. They will form cations, positively charged ions. The non-metals like to gain electrons and they will form anions, negatively charged ions. 35 is the kind of table, the kind that lists a lot of different properties, and you need to know the properties for all the different structure. So we have a giant covalent structure. It's the same as giant molecular structure, so just be aware of it. It is a giant structure. These are low melting and boiling point because these are negative values. So what I can do is A and B are out because of the giant structure. Now do not just go for the highest value just because it's giant. You always have to consider the rest of them. Yeah. So a giant molecular structure conduct electricity. You see this? So poor when solid but good when it's liquid. This implies C is giant ionic structure. In fact, C has giant ionic structure. Be careful, yeah. The compound is not giant ionic structure. The compound has giant ionic structure. C is an ionic compound. So just like how you will write or how you would reason out verbally, that is essentially how you will write in paper 2 as well. So you need to be careful of what you're saying. Why am I using exclamation mark? I have no idea. Alright, never mind. So we're looking for giant covalent structure and the electrical conductivity in solid and liquid. Liquid mean you melt the solid. Melting point is the temperature at which the solid goes to liquid. Pure substance, states of matter, heating curve, it will have a straight horizontal line because pure substance melt at a fixed temperature. They also boil at a fixed temperature. As you know, giant molecular structure, insoluble in water. Insoluble in water. So D is the best answer to describe giant molecular structure or giant covalent structure. Why are metals malleable? You should know property of metals other than high melting and boiling point, other than being able to conduct electricity in the solid, liquid state and the gaseous state. In fact, in any state, it can conduct electricity because of the presence of free electrons that are mobile to move to conduct electricity. But the other properties of metals, they're included in your notes and also in general for any metals, is that they can be hammered into very thin sheets because they are malleable. Alright, so you can apply force onto the giant metallic structure and the cations are being held in a layered structure, okay, held together like that by that sponge of sea of delocalized valence electron, so they can slide over each other because of the layered structure. So the layered structure is important. They can slide over each other easily upon applying force. So when we hammer metal, we are applying force and the layers can slide, like one of it can slide to the left, the other one can slide to the right because of that layered structure in a giant metallic lattice. You should be able to draw that, yeah? 37, so these are comparing these three options and you're looking for A, B, C, D. So which of the following solid contain more than one type of chemical bond? This is copper, this is zinc. Alloy is a mixture. Is a mixture of metals. Just because you have different metals, but they're still a mixture, therefore each one still have metallic bond. But each one is still metallic bond, and metallic bond is still one type of bonding because it's metallic bond. So A is out. Sorry, I mean 1 is out because only metallic bonding. Yes, you have two different elements, but you only have one type of chemical bond. Graphite is a tricky one because not only you have covalent bond, okay, between carbon atoms, but do not forget of the layered structure. You have van der Waals forces. This is your case study, right? Van der Waals forces is an intermolecular force. Is an intermolecular forces of attraction between the layers. Okay, so graphite has this, oh well, I can show you. Graphite has this layered structure. What you have is you have weak van der Waals forces. This one, well, all of this inside is a strong covalent bond between the carbon-carbon atoms. Okay, so 2 is definitely correct, and you don't really learn ice in O level, but since 1 is incorrect and 2 is correct, so it says 1 is correct, so A is out, 1 is correct, B is out, 1 is correct, D is out. A lot of these things you can do by logic. What is the point of you giving you this question? Is to highlight the fact that, you know, you can do some of this question by logic instead of knowing. Alright, so this is actually an AS level question, which is a first year of A levels, where you will actually learn ICE as part of your case study, but I don't want to mention it because it's too deep, but I just want to bring it as an example that you can use logic to tackle this kind of question. 38, which one represent part of a giant molecular structure? As I mentioned, this one is graphite, this one is diamond, and looking at the last one, they don't tell you, but it's actually Na plus and Cl minus. Because you should know, metal, non-metal, alternating cations and anions. Then you have strong ionic bonds. These are not ionic bonds because ionic bonds are uncountable. Ionic bonds are force field, not countable. You are not like covalent bond. You cannot count ionic bond. This kind of structure is simply to show that around each Na plus is surrounded by 1, 2, 3, 4, 5, 6 anions. Around the anions is surrounded by 1, 2, 3, 4, 5, 6 cations. Alright? So this is giant ionic structure, and it is not giant molecular. Giant molecular for diamond, giant molecular for graphite. Only 1 and 2 are correct. 39 more tables. So first of all, I look at melting point. This is low. Okay, so low melting point, that is very low, minus 70. So W must be simple molecular. It must have simple molecular structure. Look at W. So each of these, what can I say? Silicon with 4 chlorine. I can draw display formula because, well, I know chlorine forms single covalent bond. I know silicon forms 4 covalent bond maximum. So it's just like that. C2H5Br, carbon, carbon, hydrogen, hydrogen. Like I said in the lecture tutorial, carbon form 4 bond, 1, 2, 3, 4. Carbon form 4 bond, 1, 2, 3, 4. Hydrogen forms single bond. And then bromine, group 7, form 1 single covalent bond. This is C2H5Br. C2, 1, 2, 3, 4, 5. H5, 1 Br. Okay? And then you have HCl, like that. And of course you have SiCl4 again. So none of these are giant molecular. Each of these exists as simple molecule because I can draw it as one single molecule. One single molecule. One single molecule. Doesn't help us at all. Doesn't help us at all. Alright? Look at conductivity. Conductivity is a solid. Poor and poor. And this one is good. So you conduct electricity when it's solid. But this temperature is not graphite, because graphite would melt around 4000 degrees Celsius, way high. And I don't know the exact value, but it's around 4000 something. But graphite is one of those giant molecular structure that conducts. Other than that, it must be metal. Therefore, you must be metal. Conductivity when liquid, of course it conducts. And sodium and zinc, so these are all metals. So again, it's not helpful at all. Oh goodness me, none of this is helpful. V, what is V? V is poorly conducting when it's solid, but it conducts when it's liquid. This one is when it's molten, it conducts. So I can definitely say, I should probably improve my handwriting a little bit. So there is molten. I can definitely say V has giant ionic structure. Okay, and all of these have giant ionic structure. Okay, so we are pretty much screwed. So how in the world are we going to do this? Alright, minus 70 and 58. Minus 70 and 58. So if you have melting and boiling points, so this is a really difficult question for O level, and I'll tell you in a little bit why. Unless you know what we are looking for, you will find it impossible to do this question actually. Alright, 25 degrees Celsius is room temperature. HCl is a gas at 25 degrees Celsius. HCl already boils at 25 degrees Celsius. This one, the boiling point is 58, so I can tell you HCl is out, because HCl is already a gas at room temperature and pressure. The boiling point is 58. Okay, so what else? C2H5Br and SiCl4. This thing called hydrolysis, resulting solution conducts very well. So C2H5Br is not hydrolyzed. Okay, whereas SiCl4, hang on, I could be mistaken. Yes, no, I'm not mistaken. It will give you SiO2 plus HCl. So there are 4 chlorine. So I cannot change the constituent of the formula. This is basically balancing formula now. I cannot change HCl to have 4 at the bottom because in terms of covalent bonding, it just forms a single covalent bond like that. Therefore, I must have 4 HCl. 4 HCl meaning 4 of the molecules. That will give me 4 Cl on the right hand side. That will give me 4H. I cannot change H2O formula. I can add a 2 in front to give me 4 hydrogen. And that will give me 2 oxygen, and this equation is balanced. This HCl, and you also have water. So together, HCl and water, you will get H3O plus Cl minus. These are ions, and ions can conduct electricity very well when it's in water. When it's in aqueous solution, it can conduct, because this is insoluble. Sand is insoluble in water, but this is a gas at room temperature and pressure. It can react with water to give you ions that can conduct. Okay, so it's SiCl4 definitely, and not that. B and C are out, so between A and D. How am I supposed to convince you whether it's A or D? So W is done. U and V. U and V. Okay, now I know. It cannot be sodium because sodium melts just below 100 degrees Celsius. This is something you will learn as part of Group 1 Chemistry. If you look in the syllabus, Group 1 Chemistry is a O-level syllabus. So Group 1 does not melt at that high temperature for sodium. Sodium melts just below 100 degrees Celsius quite easily. So U cannot be sodium, and therefore this answer must be D. Okay, I would not be too worried if you can't do this question. This question is extremely difficult because this question comes from AS level multiple choice question, which is actually the first year of A levels. Okay, so my bad for including this question, but I just want to highlight the point, the difference in standard. That the higher you go, the more kind of information you need to break down in order to do a certain multiple choice question. But I can tell you this information you will definitely learn in all level. Okay. Anyway, question 40 hopefully will be a little bit more simpler. 3 compounds have the physical properties as usual: melting and boiling point, and then electrical conductivity when solid, liquid, aqueous. Aqueous mean in water, so liquid does not mean in water. Okay, liquid mean when you melt the solid. These two are pure substance. Aqueous is mixture, is in water. Okay, so looking at the melting and boiling point, the only one which is quite low is going to be this. This is low melting point and boiling point. This is simple molecular. Just like the previous question, HCl and NH3 is a gas at 25 degrees Celsius. It's a gas at 25 degrees Celsius. You have come across these a lot of times in diffusion. Okay, remember your diffusion, the white color ring, when you have NH3 diffusing with HCl, they have different molecular mass. One is lighter than the other, therefore this will travel further, and it will form a product closer to the HCl because HCl is heavier, and then you should show by working out the relative molecular mass and working out the relative molecular mass. And they will give you a product, NH4Cl minus. Okay, so this is called ammonium chloride. So guess what? That is an ionic compound because you have got positive charge and negative charge. But there is a different reaction. That is not the same reaction here. This is about properties. So because those two are gas at room temperature and pressure, I hope you can relate to your states of matter. Here for R, you have 39 degrees Celsius and minus 119, melting point, boiling point, 25 degrees Celsius, room temperature. So at 25 degrees Celsius, this thing is still a liquid. Okay, so it cannot be A or D because that thing is already a gas at room temperature and pressure. So B and C are the same thing. R is sorted out. Okay, now between P and Q, so this is giant molecular, this is giant ionic, this is giant ionic, and this is giant ionic. But between, if you go for B, you will see Mg2 plus O2 minus versus Na plus and F minus. This is exactly what I said in class. Plus 2 versus plus 1. Minus 2 versus minus. Oops, sorry. Yeah, okay. Higher value of charge. So I'm looking at just a numerical value. Therefore, stronger ionic bond to be broken to melt MgO than NaF. So we will expect MgO to have higher melting point because it would have stronger ionic bond because of the bigger charge of the cation, bigger charge of the anion compared to Na plus and F minus. So looking at the melting point and boiling point, you can see that P is higher than the Q. But there's the same for giant molecular and KCl, so it's difficult to say really just by looking at these. We should really look at conductivity when solid, liquid, and aqueous. So both are poor when solid, both are good when liquid, but in aqueous solution. So we know ionic compound can dissolve in water. Ionic compound dissolve in water, but it says P is insoluble. So this is important. Ionic compounds like to dissolve in water. I'm not saying all ionic compound will dissolve in water. I'm saying that most ionic compound. Be careful about most and all. I did not say all. I say most like to dissolve in water. And this is insoluble. This is sand, SiO2, silicon oxide. So C must be the answer because MgO can dissolve in water. MgO can dissolve in water because it's an ionic compound and most ionic compound like to dissolve in water. Okay, so that's the end of these 40 question work 4 multiple choice questions. Very easy to make mistakes. There are some tricky questions. I think there was 1 or 2 questions that were repeated. Overall, I hope you appreciate the level of knowledge that you need. It's the similar kind of knowledge, especially knowing your case study for the 4 different giant molecular structure, giant ionic structure, giant metallic structure, and simple molecular structure. For simple molecules, there are quite a lot of molecules with the formula. They are part of your chemistry vocabulary as stated in the syllabus. For giant ionic compounds, there's a lot more than NaCl and MgO that you need to know, but predominantly most of the time you really must know NaCl and MgO because those are the most basic case study as stated in the syllabus. And of course, any metals and non-metals most likely you'll be ionic, and you'll be able to tell from a table of properties being provided in terms of electrical conductivity, in terms of a melting or boiling point, all that kind of properties. All right, so ask me if you got any questions. If you are watching this on YouTube, then feel free to raise up any questions in the comment sections. And thank you for watching. And don't forget to subscribe to the channel and share the channel widely with other people. And you can browse through the creator topical playlist for other useful content as well. And yeah, follow me at ptet.chemistry. That is ptet.chemistry on Instagram, Facebook, and Twitter if you use this social media platform. So once again, thank you for watching, and I'll see you in the next tutorial video.